Jai Hind everyone. My name is Pooja Pandey and I am assistant professor in the MCA department in Ajay Kumar Garg Engineering College. And today I am going to deliver a lecture on the topic that is polygon clipping algorithm, in which I am going to discuss the topic that is Sutherland algorithm. And it basically comes under the subject that is computer graphics and animation. So let's start the topic. Before discussing about the polygon clipping algorithm, let us discuss that what do you mean by the polygon. We should know that everyone know that what is polygon. Even maths students know that what do you mean by the polygon. But let us take a recap for this. Polygon is mainly, it is a closed figure formed by joining three or more straight line segments end to end, right? So if you are seeing all these pictures, these are the examples of the polygon. If you see the line segments, these line segments are called the edges, and the meeting point where these sides are met, they are called as the vertices. So normally we say that the simplest polygon is a triangle, and the triangle has got the three sides and the three vertices. So we can, in short, we can say that the polygon may be of any size, right? So now we have understood that what do you mean by the polygon. Now we should know that, see, polygons can be divided on basis of these three categories. Okay, so these three categories are very important to understand when we are studying the subject computer graphics and animation, because when we are working on the pixels, or we say we are talking about the aspect ratio, resolution, these all things should be very clear for each and everything, that the polygons in terms of the graphics, it is divided on the basis of your shape, number of sides and the regularity. So in today's topic, in today's presentation, we are going to discuss only about the shape, that is the convex, concave and the complex. That what do you mean by this, all these things. Number of sides, we can understand that triangle is 3 sides, quadrilateral is 4 sides, pentagon is of the 5 side, hexagon is of the 6 side, and so on. So polygon can be of any number of the sides. When we are discussing about the polygon, in the previous slide we have discussed that the triangle has the simple, it is a you can say basic, or it is a normal polygon which has got the 3 sides. Other polygon, their sides can vary, right? So when we are talking about the regularity, now in the regularity, the two polygons regularity, the polygon is divided into the two parts, that is your regular polygon and the irregular polygon. And when we are talking about the regular polygon, it means that all sides and the angles are equal. Okay, when we are talking about the triangle, its all sides are equal, right? When we are talking about the quadrilateral, its all sides are equal and its angles should be equal. But when we are talking in the regularity, in terms of the irregular polygon, their sides or angles are not equal. So that we have to keep in mind that these three are the criteria, or these three are the base in which we divide the polygon, that is your shape, number of sides and the regularity. And we have to keep in mind that in this presentation, in today's presentation, I am discussing about the shape, that is convex, concave and the complex. So what do you mean by the convex polygon? Polygon, it means that you have to keep in mind that the polygon in which all the interior angles, you see that all the interior angles are less than 180 degree, and there is no inward, in short we can say that there is no inward banding, right? And we are saying that the convex polygon means that, first thing is that all the interior angles, if you see in all these pictures and we calculate all the interior angles of these three pictures or these three shapes are less than 180 degree, it means that there is no inward banding. Or we can say that a convex polygon is a polygon in which, if we take any 2 points inside the polygon and join them, the line segment completely lies inside the polygon, in the convex. Okay, so when we are studying about the polygon and about the top on the part of the shape, we have to keep in mind that convex polygon is a polygon. First point, that it should be a less than 180 degree, its angle should be less than 180 degree. And second point is that the 2 points, whatever the 2 points which are lying inside, whatever the 2 points we are taking inside the polygon, it should be completely inside the polygon. And when we are joining these 2 points and making a line, we will find out the line segment is completely inside the polygon. So that is about the convex polygon, right? Now, when I am going to discuss about the concave polygon, we have understood that convex polygon is that it means that we have the angle is less than 180 degree. Just opposite is the concave polygon. Here the angle is, you can say the interior angle, at least one interior angle should be more than, or you will say that it should be a greater than 180 degree. Right, or in other words we can say that the convex, or you can, in other words we can say that a concave polygon is a polygon in which there exists at least one pair inside the polygon, such that the line segment joining the 2 points or 2 points in the polygon, some partially the line segment, partially line segment should lie outside. If we are, for example, I want to say that when we are joining the 2 points inside the polygon, partially the part of the line segment should lie outside the polygon, then only it will be called as your concave polygon. So if you clearly see these all diagrams, you will find out that the points here, if I am joining this point and this point, you will see that line is partially outside the polygon. It means it is a concave polygon. Here also, in this picture also, the line segment is partially outside the picture. So this means that it is a concave polygon. So that what I am discussing, that concave polygon, you have to keep in mind when you are discussing or when you are taking the concave polygon. Two things should be kept in mind. First, one of the interior angle will be greater than 180 degree. Second, partially the line segment will be the out of the frame. So, okay, when we are joining the 2 points or when we are making the line segment, that line segment, partially the part of the line segment will be the outside the polygon. Then only it will be called as your concave polygon. Now, convex polygon. Convex polygon means that a complex polygon means that it is a polygon whose edge intersect and or overlap each other. If you see this triangle, this is a star-shaped triangle. Here you see that edges are intersecting, right? Here the edges are, if you see, the edges are intersecting, or we can say it is an overlapping. Then this will be termed as your complex polygon. Or a complex polygon is a polygon in which at least 2 edges intersect at a point other than the vertices. So you have to keep in mind that in computer graphics, the algorithm, if we are taking an algorithm, it will behave differently for the concave, it will differently behave for the convex and the concave. And the classification, that is why the classification is very, very important, right? That's why we are taking, or that's why when we are discussing about the shape, we are making it clear that what you mean by the concave, convex or the complex, because the algorithm will act differently on different shapes, right? So now let us discuss about the polygon clipping now. Here in this polygon clipping, you mean that we know that clip means that we are just editing the picture. When you are editing the picture, it means that you are clipping the picture, you are cutting. For example, you are taking a full body photo and you want that passport size photograph from that. What you are going to do? You are clipping that picture from and that means you are editing that picture, right? So that is the meaning of the clipping. Now, when we are talking about the polygon clipping, it means that the polygon clipping is a process of removing the parts of the polygon that is lying outside of the window. We already know that what do you mean by the window, what do you mean by the viewport. So that I'm not going to discuss, but here I'm just saying that polygon clipping is a process of removing the part of the polygon that lies outside the clipping window and keeping only the visible portion inside the clipping, right? For example, this diagram is very not clear, so I am drawing the same diagram here. If you see that this star has been made, right? If you see this, so in polygon clipping, what we will do, we are discarding this portion, and this portion, this portion, this portion. Okay, so we are keeping this part only in the polygon clipping. That is known as your polygon clipping. In the line clipping, what will we do? We only check that, for example, in the line clipping, if we are seeing that the parts, we are seeing that this, or we are only clipping this line. Okay, the line which is outside the rectangle, it is the we are discarding that, and we are taking the line which is inside the rectangle, or that is inside the window. So that is called as your polygon clipping. When we are discussing about the we are removing the parts of the polygon which is lying outside the polygon, we are saying that it is a polygon clipping. Now, we have to keep in mind one important point. We have to keep in mind that each edge of the polygon, it must be tested against the window boundaries. It means that we are testing all these against the window boundary. So whichever the part which is lying outside the window, we are discarding it. So that is what your polygon clipping. So in the polygon clipping, we are just discussing, that is the main topic of your today's presentation, that is the Sutherland-Hodgman polygon clipping algorithm. The Sutherland-Hodgman algorithm is normally used to clip a polygon against a convex clipping. That we have to keep in mind, that we are clipping a convex clipping window, right? In this method, the polygon is clipped. That is a step we have to keep in mind, that in this polygon, the polygon is clipped boundary by boundary. We have to keep in mind the first point in the polygon clipping algorithm. In this polygon clipping algorithm, we have to keep in mind that the polygon is clipped boundary by boundary. That is left, right, top and the bottom. This we will discuss in the in my next PPT, that how we are clipping the boundary by boundary. For each boundary, what we have to keep in mind, that each edge of the polygon is tested, right? Each edge of the polygon is tested. Second, intersections are calculated if needed. That we have to keep in mind. First is edges. Each edge of the polygon is tested, and second, the each intersection points, where my lines are connecting, or where my points are intersecting, where two lines are intersecting, that intersection points are calculated if there is a requirement, right? Second, a new vertex list is formed. You can see that when we are clipping, new vertex will be formed, right? So that we have to keep in mind. So that is what about the Sutherland-Hodgman polygon clipping algorithm. Now in detail, if I see that what I have discussed, if you see in this figure, that first is left. It means that we are clipping the left edge, right? Second is your right. Again, we are clipping the right edge. Then third is your clipping the top edge, right? And then your bottom edge. So this will be your final picture after clipping according to this polygon algorithm. What we have to keep in mind, it is a very simple algorithm. Just you have to keep in mind that first we have to clip the left side, then right side, then top and then bottom. So whatever the lines are coming outside the window, we have to clip according to this procedure. So this is what about this algorithm. But there are certain points we need to discuss about this algorithm in detail. So we will proceed towards that. That first is your inside outside test that you have to keep in mind in this algorithm. For that, each clipping boundary, a point is considered inside. You have to keep in mind that point is considered to be inside, that if it lies within the clipping region, right? And if it is outside, if it lies outside the clipping region. So that is what your inside outside test. For example, if you say that we know that this is a x-axis, this is a y-axis, and if here we will take this, this is my window. Already we know if that how we are discussing, right? And we know, so this is your left boundary, right? This will be your x min, this will be your x max, this will be your y min, sorry, this will be your y min, and this will be your y max, right? So this is what we are taking. If the left boundary, if we are taking about the left boundary, the point should be if x is greater than equals to x min. That what we have to keep in mind for the inside, right? Route boundary will be inside if x is less than equals to x max. Clear? Bottom boundary if y is greater than equals to y min, and top boundary if y is less than equals to y max. This basic thing we already know when we are discussing or when we are starting the topic, that is your clipping. Okay, so we know that what do you mean by the window, what do you mean by the viewport, and how we are taking these points. This has been already discussed in the previous slide presentation, right? So that I'm not going to discuss, because I'm understanding that you all know this, because this is a this is an advanced topic in the second unit, right? So here you have to keep in the mind this inside outside test, that for each clipping boundary a point is considered to be inside if it lies in the clipping region, and if it is outside, if it is lies outside the clipping region. So that is what you have to do, the inside outside test, right? Now there are the 4 cases I have taken for you all. Here are the 4 cases: out in out, out. This is an example we will discuss very well. Here if you see that in this there are 3 vertices, V1, Vi and V2. Okay, this is a vertices. Here if you see that if we clip, if I am discussing about the previous slide, that is x greater than is equals to x min, it means that only Vi and V2, this part will be considered for the this polygon, and this remaining part will be, you will say that it will be clipped. That is what we are saying out in, right? Here in the second part, if you see that we are this V1 and V2 are already inside the polygon, so it is an in part, right? Here it is, if you see that in and the out, here again this V1, Vi and V2, this V2 is the out part. So that is what we are saying, that in and the out, right? Here if you see in this, that V2 and V1 both point, both line segment, this line segment or this end point, both are out. So that is a out. That is what we are going to discuss in further, that we are working on this principle. There are 4 cases that you have to keep in mind, that is out in and in out and out. Why we are taking, if you see, this is a V1 and V2. So we always start with the vertex V1. So V1 is out and V2 is in. That's why I am saying out in. Here it is V1 and V2 both are inside the polygons. That's why we are saying that in, right? Here it is taking is V1 and V2. V2 is the, we will always start with V1. So it will be in and out. So that is in and out, right? Here it is V1 and V2 both are the out. That's why I am saying that out. So this is what about the Sutherland-Hartman algorithm. So according upon that previous slide, that 4 cases, we have the 4 possible cases for any given edge of the given polygon. The first one is that both vertices are outside, inside. It means that only second vertex is added to the output list. This we are going to understand clearly in my next slide, right? Now, second is your first vertex is outside while second one is inside. That also we have discussed in the previous slide, and further in detail I am going to discuss in my next slide. Right now, both the point of the intersection of the edge with the clip boundary and the second vertex are added to the output list. This you have to keep in mind, these points. Then third point is that first vertex is inside while the second one is outside. Okay, both inside, it means in. First vertex is outside and in, right? First vertex is inside while second one is outside. It means inside and outside, and both vertices are outside, that is outside. That what we have discussed in the previous slide, right? Now, how we are going to take? Now we are going to discuss. See, here let us consider that we are taking that, let us consider that there is a line segment that is A to B, right? And this is a left side. If you see that the P1 and P2, if I am considering the edge, that is P1 and P2, it means that the P1 and P2 both lies left of the edges. It means that we say that this is an output, so we add P2 to the output list, right? Now, if here in this line segment, if P1 and P2 are on the edges, on the right of the edges, and we are considering it as a outside of the line segment, we are considering the this part right side as a you say the outside and left side as a inside. That's why we in the previous we have taken it as a inside in, and here I am taking the right side as an edge, as an outside part, because if you see that what I have said, the clipping polygon is positively oriented. The points to the left of the edges are considered to be the inside, and points to the right of the edges are considered to be the outside. And this is a left side, that is why we are taking P1 and P2 as a inside part. And here in the edge, if you see that P1 and P2, this line segment is at the right of the edge, that's why we are taking as the outside and we are discarding the edge, right? In the case 3, if this is a left side, this is a right side. Now, if P1 is outside and P2 is inside, there will be an intersection point here and we will add P2 here. So that is a case 3, right? And now if P1 is inside and P2 is outside, then add intersection point here only. Okay, the diagram is here it will be the P2, here it will be the P1. According to this, there is a correction. Here it is P2 and here it will be a P1. Now it will see that if P1 is outside and P2 is inside, then add intersection point and add P2, right? And here it will be P1 is inside and P2 is outside, then add intersection point only. So this is what we are discussing, and this is the steps. These are the 4 steps where we normally use when we are discussing this or when we are working on this algorithm. So now let us discuss the algorithm. That is a algorithm. We already have understand that first what will be the step. If you recall the steps, first will be that you have to read the coordinates of all the vertices of the polygon, right? You have to understand for example, this is a window and this is a you can say this is a your polygon. So you have to read the coordinates of the, first you have to read the coordinates of the polygon. Then you have to read the coordinates of the clipping window. Now consider the left edge. Compare the vertices of the edge of the polygon individually with the clipping plane, and this comparison will be done on the 4 possible cases what we have discussed in this previous slide. According to that, we will work it on. First, we will clip the left part, then we will clip the right part, then top, and then the bottom. So finally, our figure, our diagram will be like this, if you will say that. It will come like this, and this is the resultant, you say, polygon after the clipping. Okay, so this is what we will do this if the picture is very big or many vertices are there, or many, for example, in the pentagon or in the hexagon, these 4 cases will be repeated until it will be repeated each time until the all the polygon edges or all we are getting the clipped picture of that polygon. Till we will repeat this 4 and 5 steps if we are working on the hexagon or we are working on the pentagon, right? So after that, when we have successively passed the next process of the clipping window, we will stop this. So this is what about your Sutherland-Hodgman clipping. So thank you all about this algorithm. Hope you have understand, and thank you all. Jai Hind.